Hi, I want to welcome you to this video about factoring polynomials. This is in section 1.5, open stacks for college algebra. And before we got started with the factoring, I wanted to go over a few terms. So binomial means you have two terms. A trinomial means you have three terms. The greatest common factor, also called GCF, means that a term, such as 3x squared, divides evenly into both of these terms. A perfect square is, for example, 25, and the exponent is this little number here, which you've probably seen before. And then we have two special types of factoring that we're going to be doing. One is difference of squares and a perfect square trinomial. The way you can tell when you're factoring is the first and the last terms are perfect squares. So that's why it's good to know perfect squares. Okay, now there's some letters here. This is A, B, and C, and so we'll notice is mostly we'll be working with trinomials, and the first coefficient is A, the second is B, and the third is C. So if you look at this trinomial, notice that this is A, 2, 5, and then don't forget the sign. This is really important. Notice that C is -3 because that minus before the 3 will carry on to the coefficient A, B, and C. Now, in order to use the A, B, and C method, you always want to make sure that your polynomials in descending order. Most of our examples will be in descending order, but sometimes you will have to put them in order. We're going to go over factor by grouping today as a technique. Um, I wanted you to look at these two right here. Notice this does not have an equal sign, so this is considered an expression, and this is an equation. Now, right now, we're not going to go over the quadratic formula, but I just want to let you know that factoring is one way to solve polynomials, uh, trinomials to the second degree power, but we're going to go over factoring, and that's another way to solve. Today, we're not going to be solving, though. We're just going to be working with expressions. I just realized you couldn't see the quadratic formula. Here you go. There's the quadratic formula. So if I went a little fast over this, this will also be posted so you can look over all the examples more closely. Before you start factoring, you need to find the greatest common factor. So once you have more than one term, so here we have a binomial. When you're looking at these, the simplest way to look at these is if you factor out the greatest common factor. So in order to find the greatest common factor, you can break each number down. The factors are 6 or 1, 2, 3, 6. That means each one of these numbers divides into 6. And here are the factors of 15. Now, the word common means what is a number they have in common that they can divide evenly into. And in this case, it's 3. So in order for you to factor, you actually are dividing each one of the terms. So the first term was 6x and the second term was 15 in order to factor the trinomial. So I'm sorry, this is a binomial. So let's do a problem together. So sometimes you have to spend a little more time figuring out the GCF, but the thing is the GCF here is 4. Now, what if you said 2? Well, if you said 2, you just have to do this process twice if you didn't pick the greatest common factor. Okay, so what I'm going to do is I'm going to divide each one of these terms by 4. Now I'm writing it out. You do not have to write it out. If you want, you can skip this step. It just depends on what will work for you. Now, the GCF always goes out on the outside of the expression. And then what we're going to put in the inside is the 3x. Now I'm going to show the check so you can kind of see that you know if you did the correct if you're like, did I even do this correctly? Well, if we work backwards, which is using the distributive property, we multiply 4 times 3x. minus 4 times 2. And notice that we have 12x um, minus 8. And does that check? Yes, this is what we started with. So you can always actually go reverse to make sure. That's one thing nice about algebra. Okay, so the greatest common factor can also be a variable. So the variable here is x. X, as you know, is very popular. And so if you look at these two terms, you basically have to pick which one has the lower degree. So the lower degree is the smaller number. So you have x to the third power, x to the second power. And so once you have that lowest degree, then you divide each term just like we did before. Okay, so x third divided by x squared equals x. If you need to write it out as you're kind of getting used to being back into algebra, if it's been a while, remember you can always kind of visualize that x to the third over x squared is x, because these will just, when you divide them, they are equal to 1. Okay, now that you've divided each one, x and 5, and we don't have any negatives here, then you have x plus 5, and then the GCF, of course, is in the front. Okay, so let's do an example. Our example here is to factor 4x to the fourth and x squared. Let's first start with the numbers. What is the GCF of 4 and 10? So that would be 2. 2 goes in both of them. And then pick the lowest exponent, which would be 2, and that's our GCF. So now what we're going to do is we're going to divide both terms by the GCF. And then remember, keep that subtraction, because that will also carry over. Okay, so I didn't quite give myself enough room here, but this is 2x squared. 4 divided by 2 is 2. X to the fourth divided by x squared is x squared. Negative 2 divided by 2 is negative 5. X squared divided by x squared is 1. Do we write the 1? Well, in this case, we don't need to write the 1 because it's just negative 5 times 1. So you can get 1 in this example. So what we're going to do is we're going to start with the GCF, and then we're going to put in what we divided. So we're putting that 2x squared here. These happen to be the same, which is not always true. And then we put that negative 5 times 1. Okay, now these are the steps we're going to go over, because we're going to use these techniques when we're factoring trinomials. And so we've gone over descending order, GCF, factor out. So we've gone through the first 3 steps. And then we can have the difference of squares if we have a binomial, so we'll be checking that. And then we have 2 types of trinomials we're going to do today. That's old. Okay, so always check to see if you can factor more. Okay, so usually the way I show factoring, if you need a refresher on factoring, is by using the diamond method. The reason it's called a diamond, I couldn't seem to do this part in the computer, is because this makes a diamond. Okay, so the first thing you have to always ask, is there a common factor? Is there a number that goes into all 3 terms? No. Then you can go forward. What is B? 11. What is C? 24. So just remember, we're not looking at actually the X, we're just looking at the coefficient. So what we do is we put 24 at the top of the bottom, and we put 11 on the bottom of the diamond. Now, in order for us to figure out, now I already have the answers here because this is worked out, but we'll do one where we don't have it worked out, is we have to determine what factors of 24 will add up to 11. So 24 has a lot of pairs of factors: 3 times 8, 2 times 12, 1 times 24, 6 times 4. Those are all factors. Now, only one of these pairs actually, so if you like puzzles, you like factoring, because only one pair will work: 3 and 8. So 8 times 3 is 24, and 8 plus 3 is 11. And If there are no subtraction, the next one we'll do with a minus sign, but if there's no minuses, then you have factored. Now, remember that if I multiplied this out, I would get this trinomial. Okay, so that's the diamond method. So we'll use that to factor number one. So I put C on top and I put B on the bottom. Okay, now notice that there's no number in front of x squared, so this is technically 1. So what we're doing right now is when a equals 1. A is 1, B is 2, and C is negative 15. Okay, so we have to think of the factors of negative 15. So now the thing is with 15 or negative, we know that one has to be negative and one has to be positive. Now, there's not a lot of factors of 15. So hopefully right away you see, well, it has to be 5 and 3. Now, this is where you have to use what you know about negatives because this is a positive 2. So I have a positive 2. So if I have a positive 2, which one has to be negative, the 5 or the 3? Well, if my answer is going to be positive, then the bigger number needs to be positive. Okay, so that means I'm now done with factoring. I think I'll show the check in this one just so you can see it. I also use the box method when I'm multiplying so you can kind of see this here. So I'm just going to do the check down here. Just do the check down here so you can see that you can always check your answer for this. So we have x plus 5 and x minus 3. You can also use the FOIL method. You want to use whatever method that you are comfortable with. So I'm multiplying x times x times negative 3, x times 5, and negative 3 times 5. And that when you add those all together, now we can simplify this because the 5x and 3x are common terms. And then we can check that, yes, this is indeed the correct way to factor it. Okay, so that's something that you can always use. Now, if we look at number 2, notice that number 2 is not a trinomial, so the diamond method doesn't work for that. So basically, when we have this, we're just going to have to factor. So we first have to find the GCF. So what is the GCF? Well, does 7 and 9 go into anything? No. So that's just 1, but we don't have to write the 1 if we don't want to, but sometimes it helps to write the 1. We can always drop it later. So then basically K divides into both of these, okay? So how many times does K go into 7K? Now, I'm not going to write out the division, but remember, you can always write it out if that's helpful. Now, this is an expression, and we have factored out the K. Okay, so we have 3 more pages to go. What we're going to start with is this, and we ask the question, does this have a greatest common factor? And the answer is yes. Hopefully you see that it's 2. That means 2 divides into each one. So I'm going to divide each term by 2. Now this 2 is just kind of hanging out. It's just like a cheerleader on the outside. It's not really going to do anything, but we can't drop it. But now we're going to use the diamond method on the terms that are inside. Okay? So A, now that with ignoring the 2, at this point, we have A is 1, B is negative 9, and C is 20. Okay, so I'm going to show using the diamond method again. What are the factors of 20? Well, again, since we have a negative, remember we have to include plus or minus 5 and 4, plus or minus 10. Now, you don't have to keep writing because hopefully you notice 5 and 4 add up to 9. So again, sometimes you'll get the numbers right away. And so since these add up together, now this is always a little tricky because remember, a negative times a negative is a positive, but a negative times negative plus a negative is a negative. Negative times a negative is a positive. So both of these terms right here are positive. Okay, so remember I said don't drop the 2. The 2 is still there. And then what we do is we take what's in the diamond, and this is then the factored trinomial. Okay, so this could have been an x. This can be any GCF here, but you always want to check if there's a common factor. Okay, so the next thing we're going to look at is two special cases. You can also use the diamond method if you don't want to use the shortcut, but the shortcut for the perfect square trinomials is that if you look at the first and the last term and they're perfect squares, then you can use the square root of them. So what's the square root of 4a squared? You don't worry about the absolute value when you're doing this particular problem. And what's the square root of 9? So that means that this polynomial or trinomial, excuse me, this trinomial is going to be 2a plus 3 squared. Now remember, that squared means it's 2a plus 3 times 2a plus 3. And this is called perfect square because whenever you multiply anything, even an expression times itself, you get a perfect square. Okay? Now, the worked example for a difference of squares, whenever you see a binomial, so this is a binomial, but notice there's no b. There's an a and there's a c, but there's no b. When you don't have a b, then that you want to see whether or not that this could be a difference of squares. How can you tell? Well, you look at the first and the last term. Are they perfect squares? Which they are. So then you can factor it like this as just a shortcut. We'll do an example. Is this 25 a perfect square? Yes. Is 81w squared a perfect square? Yes. So in order to factor this, you take the square root of 25, you take the square root of 81w squared, and then you just basically, now you have to go in the order. So this is going to be the first in there. So we have 5. And notice you have a plus or a minus. You can write it in either order for the plus or the minus. Plus or the minus, if you're curious, actually drops the b. That's why the b is gone. It disappeared. Now, sometimes students think, oh, well, I can just switch it because it looks weird with the variable there. I just want to let you know if you do switch it, it actually is the opposite. So you actually have to make it negative. So just remember that. Sometimes students are excited about switching, but it's not exactly the same. It's actually the opposite. So make sure you include that negative. Okay, so we only have a couple more examples to go. You might be wondering, why are we factoring? Well, one of the reasons we factor besides solving equations, we also use it for simplification. So if you look at this, this is the difference of squares. So I factor the numerator and the denominator, and we can cancel these out because x plus 3 divided by x plus 3 is 1. Okay, it's not equal to 0, it's equal to 1. So there's this imaginary 1 out here that we don't have to put, and so we're left with x minus 3 and x minus 4. Now some people get so excited, they're like, oh, well, can we cancel the x's too? No, you can only cancel when there's multiplications. Notice how these are all multiplying with those parentheses. No multiplication here, is subtraction. Okay, so the next thing we're going to do is we're going to do the most complex part of factoring. And some people end up, when they're solving, they decide just to do the quadratic formula, but I want to show you how to use the diamond method with this too. So the way you use the diamond method is instead of using the same letters, as soon as A is not equal to 1. So notice this is not equal to 1. What's the first question we were supposed to ask, though? Is there a common factor? No, all three of these are prime numbers. So we're going to use A and C. So A times C is 6. Now also watch the negatives. There's no negatives here. Okay, so that is the way, if you want, you can set up the diamond. So what you will need to do is find two numbers whose product is 6 and whose sum is 7. So we're again looking at the factors of 6. We have 6 and 1, 2 and 3. Okay, so you probably know what pair we're looking at. We're going to rewrite the trinomial using the pair 6 and 1. So that means 6 and 1 are going to be our two pairs. Now we do something a little different. We actually split the middle term. So notice how the middle term used to be 7x, and now we rewrite it as 6x and 1x. Where do we get the 6 and the 1? We get it from right here. That's where we get the 6 and 1. Now the reason it's called factor by grouping is we are going to factor terms 1 and 2, they're in yellow, and terms 3 and 4, they're in blue. Okay, so the way we factor them is we get the GCF. So you can see how important the GCF is. Put it here. And the GCF, now I wrote a note. We actually write out 1 in this process. We write that 1. And then we take these two numbers here, 2x plus 1. You have to use this sign, whatever it is, 2x plus 1. And then you factor it out. And this is factor out the x plus 3. And there it goes. So this 2x plus 1 is related to these numbers in front, and the x plus 3 is the common factor. Now, you know you did it right if these are the same, okay? But like I said, we're going to do one more example. Okay, so this is our last example. I do want to just say that the best way to do these is just to keep practicing, and you'll just get better at it the more you do it. Don't worry, we'll be doing it all semester. So again, we have A, B, C, and we check, is there a common factor? No common factor. Okay, so up here, we put A times C. So A times C, and that's 24 and negative 10. Well, we already did all the factors of 24, but remember, we can just write them out again. So this is negative, so we have to think of the plus and the minuses. Okay, so I'm going to stop there because I noticed that 12 minus 2 is 10. So, but 12 minus 2 is 10, but I want a negative 10. So that means for um, the terms that I'm going to use to complete factor by grouping, I'm going to need a negative 12 and a positive 2. Well, look at that. That doesn't work, does it? Why doesn't it work? Because a negative 12 plus 2 is negative 10, but negative 12 times negative 2 is negative 24. Okay, well, back to the drawing board. So this happens. This was not planned, but it's good for you to see that it happens to the best of us. Okay, so we need another factor then. What about 6 and 4? That might help us. It does. Okay, there we go. So we got negative 6 and negative 4. Now see with the negatives how easily it is. Now you should always check. That's why I knew I had the wrong numbers. Negative 6 plus negative 4 is negative 10. Negative 6 times negative 4 is positive 24. Okay, so this is kind of the part that always is something that you have to kind of slow down, because we have a negative 10x up here, but we're saying, no, we're not going to write it as 10x. We're going to write it as negative 6x minus 4x. Now, these are the same. This, like I said, mathematicians love to do this. They're like, hey, let's rewrite this differently so we can do a different technique. Now, the factor by grouping means now that we have it rewritten, we're going to factor these and we're going to factor these. So we need a GCF. Now this minus is very important, so don't drop the minus, because if you don't, because you see right here, uh-oh, I didn't pick the GCF. I must be getting tired because it's the end of the video. Okay, so the GCF is 4, so that's 4 times x and 4 times 2. So that's a 4. Now, what do you do to finish this factoring? You take this, and you make this into a factor. And then again, notice the negative, and then that x minus 2 is right here. Now, whenever these are negatives here, remember this negative times a negative is a positive 8. So you're actually doing a lot of negatives and positives. Now, one thing to remember, if this is factorable and you did everything correct, these always have to be the same. So it's kind of a way for you to check your work. Now, again, we could check this to make sure that we got the original one, and we might as well do that. Good practice of multiplying polynomials. You might notice something familiar. This is why we broke it this way. So now we have 3x squared minus 6x minus 4x plus 8, which looks exactly like what we had earlier. Then we're going to combine the like terms, and then we have the same exact expression that we started with. So thank you so much for watching this video. I recommend just watching different parts of it if you need it and practice some problems. Feel free to reach out if you need more help to your instructor or to your study group or the Math Success Center.